Section 9-3, continuing with Part 1. Again, this is another picture of a rotation where the center of the rotation is the origin. And you see again we had the original ABC. This is just going back over the previous example. We had the triangle ABC, and we're rotating it around here. So if I rotate this around, rotating it along B, along our rotation here, rotating it around B, okay? Rotating it all the way around, coming around, you see that B prime is still the closest one to the origin, okay? So B prime goes with B, A prime with A, and C prime with C. So this is just a visual picture of rotating around the origin, okay? So I just wanted to show you that one more time before I started section 9-3, okay? So now let's look at section 9-3, part 2. You can use a protractor to find an angle of rotation. All right, this is a protractor. All right, here is a protractor that I have. It's much larger. All right, you see that it has two scales. The inner scale starts with 0, 10, 20, 30, 40, 50, 60, so forth on. And the outer scale starts at 180, so forth on. Okay? So if I was to draw an angle and say measure the angle, you would place the hole and line it up with your initial ray. Now, a ray is a solid end on one end and a straight line on the other with an arrow on the end. So an angle is made up of two rays coming to a common vertex. So if I was to measure this angle, if I line it up and line up my initial ray, I need to determine where does my terminal ray end. Well, I can extend that ray up if I want to. I can extend that ray up, okay, so that it will meet the scale on my protractor. Now, when you line this up and you start at 0, you start with a 0 scale. 0, 10, 20, 30, 40, 50, 60, 70, 80. Looks like this angle is about 85 degrees, all right? Lining it up again. Looks like to me it's about 85 degrees. So this angle would be 85 degrees, okay? All right, let me draw another angle for us, just so we can practice measuring angles real fast. Okay. All right, so this time I drew this angle. All right, so what I need to do is place my hole right at the vertex here, placing the hole, line it up with your initial ray. Now, wherever the initial ray is touching, that's the scale that you use with 0. So this angle is 0 degrees right here, 10, 20, 30. Looks like we're about maybe 37, 38 degrees, somewhere in between 30 and 40. So this angle is about 38 degrees. We call this an acute angle, all right? Anything less than 90 is an acute angle. A right angle is 90 degrees. Anything greater than 90 but less than 180 would be an obtuse angle. So let me draw another angle for us. Let me draw another angle for us to measure. Okay, what's the measure of this angle? Lining it up, line up on your vertex right in the middle of the hole of your protractor, lining up your initial ray with the lines on the protractor. Now again, wherever your initial ray starts, that's the scale. You have to start at 0. Whether you're on the left side or the right side, it depends. You have to look at your initial ray. This is when you start at 0. 0, 10, 20, 30, 40, 50, 60, 70, 80. There's 90, 100, 110, 120. Looks like to me this is about 125, 26 degrees. So I'm going to write that as 126 degrees. This is an obtuse angle, okay? So that's how you measure with a protractor, okay? So you see back here in this example that I've been given here, you can use a protractor to find an angle of rotation, all right? Suppose you have point P. You rotate point P about a center of rotation O. So here we have point P. Point P, center O. It's rotated around to P prime. So what is the angle of rotation given here? Well, again, you can take your protractor or just look at this one that I have here. I started at, this is my initial ray. You start at 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 120, 130, and halfway in between 130 and 140 is 135. So you see here, the angle of rotation of this problem is 135. All right, so next, I want us to look at the example of finding angles of rotation. So let's find angles of rotation. What is the angle rotation about the origin that maps triangle ABC to triangle A prime, B prime, and C prime? What is the angle of rotation? All right, so from the origin, this is what I'm going to do. From the origin, I'm going to line up the origin here. I'm going to draw a straight line between that includes the origin and A. So here we have a straight line including the origin and A. Looks something like this. Okay? So I drew a straight line between the origin and A. Now I'm going to draw a straight line between the origin and A prime. Drawing a straight line between the origin and A prime. What is the measure of this angle right here? Let's measure it with our protractor. Lining it up on the 0 right there in the middle, lining up your initial ray with the lines, with the markings on your protractor. Start with 0 on the initial ray, 0, 10, 20, 30, 40, 50, 60, 70, 80. If I extend that on up, looks like that is going to be a 90-degree angle. So this is a right angle. I'm going to go ahead and square that up because a square means 90 degrees. Okay? So it says what we've done here is we have drawn the measure or concluded the measure of angle AOA prime. What is the measure of AOA prime? That's this angle right here. It is equal to 90 degrees. So I'm going to go ahead and show you down here where it was actually done as well. Drawing the protractor here. So we had to draw the angle AOA prime, and we did. So the angle of rotation about the origin that maps triangle ABC to triangle A prime, B prime, C prime is 90 degrees. So the answer to this problem is 90 degrees. So going back to my construction, I had to create a ray that passes through the origin and A. I had to create another ray that passes through the origin and A prime. Then I had to measure this angle to determine the angle of rotation. And my answer was 90 degrees.